Good morning, and welcome to Science 9 in the AM. This is Team Gary coming to you, and I'm Joel Stedelijk. We just recapped some things. We were looking at balloons, charges, and how they become negatively charged. We talked about our Van de Graaff generator now that we know a little bit more about static electricity. And now we're going to just do a few notes for our electricity units. I am recording. Your voice was recorded. So anything you say and do will be recorded. Or maybe I'm not recording. I didn't start recording. Or no, that's frozen. That's why it doesn't look like I am recording. Yeah. Okay, good. Good call. I wasn't looking behind my head. Now, here's what I want to do. You guys jot this down here because we've got to get some stuff on. We will do labs, but we have to get some meaning out of the labs too. So they're kind of fun. Then we have to reflect on what we just saw over the last couple of days. I'm going to pause the video recording because if you're watching the recording, you need to just jot this stuff down. So pause the screen. Okay, I see about half of you are done. Half of you are still jotting stuff down. I'm going to talk, and you continue jotting stuff down. I just wanted to make sure it's on paper. This phrase, electric discharge, I didn't use that. I call it grounding. The removal of electric charge from an object. And remember how I was saying I touch this tap because it's metal plumbing goes all the way to the ground when we're using the Van de Graaff generator. That's what I was first talking about. That kind of removes the excess electrons, or if I had a positive charge in my body, it would suck electrons up from the ground. Now, the reason why I'm talking about grounding the Earth, and just do a circle here for the Earth, it's such a huge thing compared to meat that give or take 100 electrons, it doesn't make any difference because somewhere, 100 electrons go this way. Well, probably somewhere in Australia or just in Quebec or somewhere else, there's 100 electrons going in from some other process. It makes there's gazillions, and we don't really have words for the amount of electrons probably on Earth. But 5, 10, 100 electrons don't make a huge difference in the Earth that it's going to add up to any major charge. Right? I guess if you could take the Earth and rub it against a balloon that was Earth-sized or something, then you'd have a difference. You don't. That's why I say ground. I mentioned this already. I mentioned it last week. So electrons are the particles that flow. Now, I think you're somewhat aware of what I'm going to put up here, and I think I'm glancing around. Hands have stopped moving. This is good. You guys are paying attention. You're wonderful. Well, we've heard about these, and my writing is mediocre at best. But here's a diagram, simple diagram of the atom. We know this, right? Like we've heard of that. Maybe. Oh. I'll see if I can just get the electrons. Sense on yeah. I'm going to just start to get typing because I know handwriting isn't everybody's. You see how I kind of color coded it, and it's really an amazing thing for me because you know me. I told you so there's negative electrons. Protons and neutrons are in the nucleus. Get them all the same size here. let's go with 18. Good size. No, that's a little small. There we go. Slowly getting stuff typed up here. Okay, that's a little easier to read now that I've got typing instead of handwriting. That's a dash, just like the point. Sleepy's handwritten. So a simple diagram of the atom. This is the first year for 24 years that I haven't taught chemistry. But I know chemistry quite well, and there's more complex models of the atom. This is the way we need to understand static. Take chemistry. If you wish to know more, take physics actually. If you really want to know how chemistry and physics combine, like crossover. They do with the. Have you heard of nuclear physics, nuclear power, and energy related? No, that's where it crosses over with chemistry. With atoms. And think of our Science 9 course as a big commercial for what you're going to take in grade 12. Chemistry, physics, biology are your choices here in this school. There's also computer science, but it's not offered at the school, but something called CRP. Okay? That's great. I think you kind of have an idea of that. There's also earth science that isn't offered here, but could be taken also through land-based education. Okay, 100%. And that's more the geology kind of stuff, which you guys don't do much of anymore. I think grade 7 and 8, you may have taken rocks, igneous rocks, metamorphic rocks, sedimentary. Some people are saying yes. Now, I know at some schools, because you usually had split classes 7/8. Is that right? And 6/7s and stuff. So sometimes when you get shifted around classes, you miss a unit because a grade 7/8 science class will usually take 2 units from grade 7, 2 units from grade 8. And then the next year, that teacher will flip them and do the other 2 units that they didn't do from grade 7 and the other 2 units from grade 8. Teach it to everybody. Sometimes you get missed if you shifted from one class to the other, and so then you miss it. Not a huge deal. Anyways, are we good on this diagram? I see the pens have stopped moving, so that's good. Okay. You can tell I usually try to rush you through notes a little bit, but I mean, I try to make sure people come. So, what we've been talking about and what we've been doing, let's get something down on paper about it. Theory of electricity. The two different types of matter are brought close to each other. One may lose electrons to the other. And I'm using vinyl, that white vinyl that we used. Wool, which is really hair, right? Okay, I'm going to pause the video because you're just going to shut up and you guys are going to write. Okay. So, right now, that's a drawing before. And then after, add this in. We rub. The electrons, you notice my minus signs increase on the vinyl strip, decrease at 4 initially on the wool. Now I only have 1 on the after, just to represent electron trends. Electrons are negatives. I'll pause my recording. You guys are going to jot this. Okay, we're going to flip the page here. I think we know this, but I want to get it in writing. 3 laws of static charge. Opposites attract. Like charges or similar charges repel. And then the other thing is that charged objects attract neutral objects. That's that thing, remember I called that styrofoam ball a pit ball? Anyways, jot those. Then we're going to get into some textbooky stuff. Okay, we got this down? Okay, what we're going to do is get into our textbooks, page 205. We're gonna skim over it together as a group. (205) to 209. And you'll see that, oh, an error while reading. That for the most part, I'm saying we're skimming as a group because I have more or less chatted it up. I'm not, if we could, oh, insufficient data, whatever. It ain't working right. Okay. So what I'm going to do is skim over this because if it's possible not to read it in a book, but do it, I prefer that. That's my whole thing. There's a good picture that didn't come up on this thing here, but there's this lightning thing here in the volcanic eruption. Lightning in Iceland's, I don't know how to, volcanic eruption. I don't know how to say it. But in 2010, Iceland's volcano erupted, spewing ash, dust, toxic gases into the atmosphere, and it disrupted European air travel for weeks. I actually do remember this as good news. Drifted over the continent. Lightning is usually associated with rainstorms. We are aware of that in summers. But bolts of lightning are also found in the middle of ash clouds of active volcanoes. While volcanic lightning remains a mystery, it results from the friction of the particles emitted from the eruption, causing a buildup of electrical charges, then a dramatic discharge of light. We have no experience here. Okay. So I do find it interesting. Things that you don't understand are interesting. Even things that we do see. We've all seen lightning and stuff like this. Some heard thunder. Even things like that are interesting, but I don't know. That one's kind of neat. I've never seen a volcano erupt. I've seen dead volcanoes like not erupt. The island of Maui has 2 big ones and stuff like that. Anyways, I don't really want to see and put myself in danger either. Worried about a volcano. Okay. Here's something else we'll just quickly read here. In the winter months, some First Nations and Métis people tell stories that explain phenomena such as lightning and volcanic eruptions. In April 2009, Mount Redoubt in Alaska erupted, and within its blast, a fantastic lightning storm took place. Haida teachings explain that Thunderbird is present in the fiery ash of the volcanoes where lightning strikes. You'll learn more about Thunderbird later in this chapter. Every culture, indigenous or Western, has its own preferred explanation. However, you guys realize that that's not science, but it's of interest. Because the way science works is that we build on knowledge and it's a way to understand the world. And it doesn't involve supernatural, unexplained. You make observations and you see if it matches up. And then you build on that set of knowledge more and more. But it usually, the initial understanding of some phenomenon in nature started out with some cultural understanding. And it worked and it served that purpose at that time. That's where we're coming from. Okay. I'm not going to talk about a shocking experience because it's talking about have you ever, put a spreader over your head. We've talked about this. We've done this kind of stuff. Okay, so I'm flipping the page there. Oh, we've talked about the idea that there's neutrons, protons, and electrons in an atom. We have a diagram, so I'm not going to continue on with that. But there's a better diagram in. We will talk about atoms and electrons in the chemistry. Now, static electric charges. We call this static electricity, even though, because for the most part, once you've rubbed the two things together, the electricity doesn't flow. Then there's current electrical energy, and that's stuff from the plug-ins into your batteries that run your calculators, your phones, light bulbs, etc., right? Okay. Right now, we will talk about current electricity, but right now we're just talking about static, where the charge builds up and then stays still until something else disrupts. Okay? And we've talked about these things, gaining or losing electrons, friction, and the movement of electrons. We figured this out without reading this, but there we are, right? So I'm just going through this and saying, hey, we've done all this. Here's something of interest, though. The triboelectric series. Which ones tend to lose electrons? Which ones tend to gain electrons? So if you take something from the top of the list and the bottom of the list, and you move them together, the top of the list ones will lose the electrons. They're going to become, if you lose negatives, become positives, right? It's like personality and stuff. I'm feeling down today. I need to do something to lose my negativity. Well, then become positive, right? You turn that frown upside down into a upside down rainbow, right? A smile. That's what you do. So if you take, say, cat fur, why not cat fur? And you take some plastic wrap, you rub your cat with plastic wrap. The cat fur will lose the electrons, become positive, real static. And the plastic wrap will become negative. So plastic wrap, by the way, we call it saran wrap often. That's a brand name, but that sticks to your bowls if there is static involved. And that's why. Okay. Static. But there you go. You get a list and you get some ideas why some combinations work better than others when you rub the two together. Okay. Electron affinity. Affinity is just a love for something. So if an object tends to love electrons, it has a high electron affinity, it'll hold on to its electrons and hopefully attract more when it's doing something. Hello. Sure, just one second. We flipped through a few different things here, electrical, insulators, and conductors. Now, you don't have to write anything down, but we're just going over this. An insulator, and I have mentioned this too, is, well, we look up at the sky here and we see the sky, the ceiling. The electrical cords that come out of the roof are wrapped up in a plasticky kind of coating. And that's because they are insulators. They don't carry electricity very well. So it's safe to grab the electrical cord. Metal, on the other hand, is a really good conductor of electrons, so therefore electricity. And I think you're aware that if you see bare wires on an electrical device, don't touch them, right? Because you will get hurt, possibly. Yes. Yeah. I fell off a ladder doing something like that too. You know how in your house you have a breaker box? Have you ever had your one breaker snap or whatever, like the power go out on, usually it's in the kitchen, and especially if you have an older kitchen or something, you run the microwave at the same time as a blender or something, just snap, and it shuts out that one circuit. Anyways, I was doing some renovation work, changing a light fixture and stuff. I really thought I had turned off the correct light because other lights were out. And I was doing the same thing. I obviously hadn't. I was on a ladder and I got a really good jolt and I fell off the ladder and it hurt my wrist. So nothing broke. It was like sore for a week. Yeah, be careful. I just did some electrical work this weekend and the breaker box where I live right now isn't labeled well. So I just thought, this is stupid. It's daytime. I'm going to just, instead of trying a million, there's probably 24 breakers, switches and stuff. My son was asleep, my youngest son. I thought, I'll just shut the whole thing off. And I did, just to be safe, because I didn't know which one was which. If you're doing electrical work, shut the things off. You usually don't get killed as long as there's no water involved. So I'm saying usually. I'm not an expert on hearts and stuff like this, though, so just shut it off. Don't take risks. Gosh, no. Those, no. I'm talking about the odd person gets a shock here and there from an electrical thing. And sometimes it is fatal. So don't mess around with anything. Okay. So good conductors, copper, aluminum, iron, mercury, other metals, insulators, rubber, wood, plastic, pure water. Pure water. That sounds silly. You know why water conducts electricity? Then because it isn't pure and it has, say, some salts and stuff. You know that our water isn't pure here. But if it wasn't pure, it actually wouldn't conduct electricity very well. But don't, tap water is not pure water. Dangerous. Absolutely. Okay, and that's what they talk about there, but more about that later. Now, I thought, no, I was going to give you some of these questions here. But you know what? We've done such a good job, and you guys are a really attentive group. I really like it. But I don't think I need to give you these questions as written questions. But let's just talk about number 4 on here, and we'll talk about it instead of doing this. 4. How would a scientist explain the following observation? A plastic rod that contains a large number of electrons does not have static charge. Yeah? Yeah, it probably also has an equal number of positive charges, really, because you hadn't rubbed it. Yeah, that's probably it. That, so it's always in relation to how many positive charges you have. So, yeah. I think we're going to get ready for another activity so that tomorrow we can maybe get juiced up on electricity again. Okay, these were the questions, though, but we already have these diagrams. What the heck? I just clicked in the wrong thing. Insulators. Okay, this is my handwriting. Who can't read my handwriting? Yeah? Okay. Well, here's what we're going to do. So we're going to jot this down so that we've got a start for tomorrow's activity. We're going to use an electroscope, lab, using an electroscope. You'll see what it is. What's an electroscope? Well, the next thing. Oh, name, title, date, but that comes tomorrow because you don't know who's. Giving you time to jot the stuff. I'm going to underline. It's just for fun. I really like my handwriting. I'm sad that you guys don't. Well, you just can't read it. Well, that's not good. this over top. Oh, son of a secret there. So those on the recording here, you're jotting this down too. I don't know. There's not too many people on. But this recording also could be useful if you're like, I don't remember what the heck. You want to review something. Yep. We'll talk about that as a group, though. Okay, this will be good enough to get started. I'm not going to get into the diagrams yet. Okay. I'm going to stop the video recording. If that's enough, you can jot that down.